Bismillahirrahmanirrahim. We are studying chapter 6, that is suspension system, and today we will cover the third part of our this chapter, that is the components of the suspension system. Previously we have talked about different things regarding the suspension system. Now in this part, the part 3, we will talk about the components of the suspension system specifically. So what are the components of the suspension system? Basically, we can conclude that there are 7 parts. We can divide the suspension system into it. First is the control arms, then ball joints, strut rods, stabilizer bar or sway bars, shock absorber, strut assembly, track bars. This strut rod and strut assembly, these are different things. Okay. So let's study one by one. First, talk about the control arms. Control arms. A control arm is a suspension link that connects a knuckle or steering knuckle or a wheel flange to the frame. So basically it is that component or that part of a suspension system which connects the steering knuckle or a wheel flange to the frame of the body. So the control arm, one end of the control arm attached to the knuckles or wheel flange, generally either with a ball joint or bushing. So one end of the control arm attached to the steering knuckle or wheel flange, generally with either a ball joint or a bushing. The opposite end of the arms which attaches to the frame member. So one end is attached to the steering knuckle or the wheel flange with the ball joints, and other opposite end is attached to the frame member, usually pivots on a bushing. So on one side it is attached to the wheel and on other side it is attached to the frame. The end attaches to the frame must pivots to allow the axle or knuckle to travel vertically. So the end which is attached to the frame must have this characteristics or capability that it must pivot to allow the axle or the knuckle to travel vertically while the vehicle is in movement. Now, first, control arms are used to connect the steering knuckle to the frame or a body of the vehicle and provides the structural supports for the suspension system. This green portion is known as the upper control arm, and this lower one is known as the lower control arm. And it is joined with this steering knuckle, and here we have this wheel flange. Okay. And this yellow portion is the ball joint along with this dust cap and castle nut and cotter pin. Same goes for the lower control arm. We have a ball joint, dust cap, and castle nut and cotter pin. So this is the one end which is attached with your steering knuckle, and this other opposite end is attached to the frame of the vehicle. So this is your control arm. And this is your steering knuckle, and here this yellow one is your ball joints. Now second part is your ball joint. Ball joints are actually ball and socket joints similar to the joints in a person's shoulder. Similar we have in our person's shoulders. The same arrangement is there in the suspension system, that ball joints which are joining the steering knuckle and the control arms. Ball joints allows the front wheel to move up and down as well as sidewise, side to side for steering purpose. So the purpose or the function of the ball joint is to allow the front wheels to move up and down, the vertical motion, and side to side in the horizontal plane motion for steering purposes. A vehicle can be equipped with coil spring mounted either above the upper control arm or on the lower control arm. We will see in this figure. So let's see, this is the coil spring in upper control arm and lower control arm. If the coil spring is attached to the top of the upper control arm, then the upper ball joint is carrying the weight of the vehicle and is called the load carrying ball joint. So if the coil spring is attached to the top of the upper control arm, means the coil spring is attached to the upper control arm. So this ball joint is the load carrying ball joint. the lower ball joint is called the non-load carrying or follower ball joint. So this lower ball joint will call the non-load carrying or follower ball joint. If the coil spring is attached to the lower control arm, so in this case, like here, the coil spring is attached to the lower control arm. If the coil spring is attached to the lower control arm, then the lower ball joint is load carrying ball joint and the upper joint is the follower ball joint. Same vice versa. If the spring is attached to the upper one, then the upper ball joint is the load carrying ball joint and the lower one is the non-load carrying or the follower ball joints. And it is, if the spring is attached to the lower control arm, then the lower ball joint is the load carrying ball joint and the upper one is the non-load carrying or the follower ball joint. Now let's see, in figure this, ball joints provides the freedom of movement necessary for steering and suspension movement. We have this frame here, this upper control arm, lower control arm, then steering knuckle and wheel flange and wheel. These are the upper ball joint, lower ball joint, and this coil spring is attached to the upper control arm. So coil spring or torsion bar mounted on upper control arm. Now in this figure, we have this upper control arm, this one, lower control arm, upper ball joint, lower ball joint, steering knuckles, flange and the wheel, and the coil spring is attached to the lower control arm. So the coil spring or the torsion bar mounted on a lower control arm. So another example, we have a McPherson strut in which we have this lower control arm, lower ball joint, and then steering knuckle we joined with the coil spring assembly shock absorber. Okay, so this is another type we will study later on. In next case, a coil spring mounted on lower control arm with modified strut. So we have a lower control arm and we have a ball joint here. The coil spring is attached to the lower control arm, then with the shock absorber with the upper part of the steering knuckle. This is another modified form we will study. Now ball joints. The upper ball joint is load carrying in this type of suspension shown in this figure because the weight of the vehicle is applied through the springs, upper control arm and the ball joint to the wheel. The lower control arm is a lateral link and the lower ball joint is called the follower ball joints. Now let's see. We have this coil spring and the shock absorber assembly mounted on an upper control arm. That upper control arm, then we have a load carrying ball joints which is attaching the control arms to the steering knuckle. Steering knuckle, we have a spindle or a flange on which the wheels is mounted. Then we have lower control arm along with the follower ball joint or non-load carrying ball joints. This is lower control and the few other assemblies. This is the strut rod along with strut rod bushing, and we have a stabilization bar also which is attached to the lower control arm in this mode. Okay, so here the spring and coil spring assembly is upper control arm is carrying the load. So the upper ball joint is the load carrying ball joint and lower one is the follower ball joint, non-load carrying load. Now the lower ball joint is load carrying in this figure in this type of suspension because the weight of the vehicle is applied through these springs, lower control arm and ball joint to the wheels. So we have this upper control arm and this ball joint, and in this ball joint is a non-load carrying and follower ball joint. We have this steering knuckle with spindle and the wheel, and then we have a lower control arm, this one, and load carrying ball joint or load carrying ball joint. The spring is attached to the lower control arm, so weight of the vehicle is on this springs. So these ball joints will be, lower ball joints will be load carrying ball joints and the upper one will be non-load carrying ball joints or the follower ball joints. Now the basic design or ball joint designs, there are two basic design of ball joints, compression loaded and tension loaded. If the control arm rests on the steering knuckle, The ball joint is compressed into the control arm by the weight of the vehicle. So if the control arm rests on the steering knuckle, the ball joint is compressed into the control arm by weight of the vehicle. If the knuckle rests on the control arms, otherwise, vice versa. If the knuckles rest on the control arm, the weight of the vehicle tends to pull the ball joints back into the control arm by tension. In first case, we have the compression. In second case, we have tension. So the type used is determined by the chassis design engineer. Which type of ball joint we have to use, the compression one or the compression loaded or tension loaded, it is the job of the chassis design engineer. And the service technician cannot change the type of ball joint used for particular operation. Normally, when we take our vehicle for repair of the suspension or ball joints to the mechanic, they do their own some sort of local engineering, and that is not allowed because the chassis designer has calculated the values and then have put it the compression or tension loaded ball joints. So service technician cannot change that ball joint design applied there. All ball joints, whether tension or compression loaded, have a bearing surface between the ball stud and the socket. So first one is we are talking about the load carrying ball joints. In tension loaded ball joints, we have this bearing here. And in compression loaded ball joints, we have bearing here. Now, the third part is the strut rod component of the suspension system. Some vehicles are equipped with round steel rods that are attached between the lower control arm at one end and the frame of the vehicle with the rubber bushing called strut rod bushing at the other end. So basically it's a rod which is attached to your lower control arm at the one end and to the frame of the body to the other end, with having a rubber bushing in between them for dampening of the noise and vibrations. So some vehicles are equipped with round steel rods that are attached between the lower control arm at one end and the frame of the vehicle with rubber bushing called strut rod bushing at the other end. The purpose of these strut rods is to provide forward and backward support to the control arms. So basically, the purpose of this strut rod is to provide the forward and backward support to the control arms while we are moving or vehicle is in move or standing. Strut rod are used on vehicle equipped with McPherson strut and many short oblique long arm type suspension system. So this strut rod is generally used in vehicle equipped with McPherson strut and many short oblique long arm type suspension. The bushings are very important in maintaining proper wheel alignment while providing the necessary up and down movement of the control arms during suspension travel. So the rubber bushing which we are using with the strut rod in the lower control arm and with the frame, that is very important for the proper wheel alignment because it not only provides the necessary up and down movement of the control arm during suspension travel. Strut rod prevents lower control arm movement back and forth during braking. So strut rod prevents lower control arm movement back and forth during braking. Strut rod are also called tension or compression rods or simply TC rods, and some manufacturers call it drag rod. The purpose we have is elaborated here more. The strut rod prevents lower control arm movement back and forth during braking. Strut rods are also called tension or compression rod or simply TC rods, or some manufacturer called it drag rod. Let's see this figure. A strut rod is longitudinal support to prevent front to back wheel movement. Strut rods are only used when there is only one lower control arm bushing and not used when there are two lower control arms bushing. Now let's see this figure. This is your upper control arm, the upper control arm shaft with bushing. Then we have the upper ball joint. And then we have steering knuckle along with this spindle, the wheel, then the lower control arm, and the coil spring is mounted on the lower control arm. So the lower ball joints are the load carrying ball joints. And then we have this rod, strut rod. It is attached to the lower control arm on one side and other strut rod and bushing to the frame of the body on the other side. And then we have some other rods also, with stabilization bar or other bars we will talk about later. So this is your stabilization bar and lower control arm bushing. So this stirred rod is mounted on the lower control arm here, and other end is to the frame, and both side we have a bushing inside. Stirred rod bushing insulates the steel bar from the vehicle frame or body. This is your stirred rod mounted on a lower control arm. Here we have a rubber bushing also, and here we also have a rubber bushing also. The fourth part, the component of the suspension system, is the stabilization bar. Most cars and trucks are equipped with stabilization bar on the front suspension, which is round, hardened steel bar, usually SAE 4560 or 4340 steel, attached to both lower control arms with bolts and rubber bushing washer called stabilization bar bushing. So this stabilization bar is also attached to the lower control arm. So most of the car and trucks are equipped with this stabilization bar on the front suspension, which is a round hardened steel bar, usually Society of Automotive Engineering number 4560 or 4340 steel, attached to both lower control arms with bolts and rubber bushing washers called stabilizer bar bushing. A stabilizer bar is also called an sway bar or roll bar or stabilizer bar, operated by twisting the bar if one side of the vehicles move up or down in relation to the other side, such as during cornering, hitting bumps, or driving over uneven road surfaces. So basically, the stabilization bar is also called an anti-sway bar or anti-roll bar. A stabilization bar operates by twisting the bar if one side of the vehicle moves up or down in relation to the other side, such as during cornering, hitting bumps, or during over uneven road surfaces. Let's see. We have this upper mount assembly. This is a stirred assembly. We have this spindle wheel arrangement here. This is a spindle. This is a steering knuckle. And then we have a lower control arm. This is the Stewart rod along with Stewart bushing. And this is lower control arm. Then we have this stabilization bar link bushing. And this is the anti-sway bar or stabilization bar with the stabilizer bar bushing, and then stabilizer bar link attached to the other end. And this is your ball joint and the coil spring assembly. This is your stirred rod. So typical stabilization bar installation is like this: the frame of the body, the lower control arm, it is attached to the lower control arm, and it goes to the other lower control arm with having a rubber bushing or stabilization bar bushing between them and linkages. So as we have studied here, the stabilization bar operates by twisting the bar if one side of the vehicle moves up or down in relation to the other side, such as during cornering, hitting bumps, or driving over uneven road surfaces. And in this figure, if the body is leaning on this side, as the body of the vehicle leans, the stabilizer bar is twisted. This stabilizer bar is twisted. The force exerted by the stabilizer bar counteracts the body lean. So it will help the vehicle not to topple and to get back to the original position. Stabilization bar, as we have stated, the purpose of the stabilization bar is to prevent excessive body roll while cornering and to add stability while driving over rough road surfaces. The stabilizer bar is also used as longitudinal front oblique back support to the lower control arm on many vehicles equipped with McPherson stirred. The effective force of the stabilizer bar is increased with the dia of the bar. So the effective force of the stabilizer bar is increased with the dia of the bar. Therefore, optional suspension often includes larger diameter stabilization bar and bushing. So more the dia is, more the effective stabilization bar is. Stabilization links connects the end of the stabilization bar to the lower control arm. Let's see. Just to summarize, the stabilization bar or sway bar or anti-roll bar used to keep the body from leaning excessively in sharp turns made up of spring steel, fastened to both lower control arms and to the frame. When the body leans, it twists the bar. The bar resists to twisting limits. Body lean in a corner. Sway bar links connects the bar to the control arm. So we have a frame and this is the linkage, bushing, and sway bar, bushing and linkage is the same thing which we have studied. Now the next part is the shock absorber of the suspension system. The major purpose of any shock or strut is to control ride and handling. The major purpose of any shock or strut is to control ride and handling. Standard shock absorbers do not support the vehicle of the weight of the vehicle. Standard shock absorbers do not support the weight of the vehicle. The spring supports the weight of the vehicle. The spring supports the weight of the vehicle. We have studied this slide, sprung weight and unsprung weight. The shock absorber controls the action and reaction of the spring. So basically, the purpose of this shock absorber is to control the action and reaction of the spring. Most shock absorbers are direct acting because they are connected directly between the vehicle frame or body and the axle. Most shock absorbers are direct acting because they are connected directly between the vehicle frame or body and the axle. We will see in the next figure. As the vehicle wheels roll over a bump, the wheels move towards the body and compresses the springs of the vehicle. As the spring compresses, it stores energy. The spring then releases this stored energy, causing the body of the vehicle to rise, rebound. Let's see. We have this frame here and we have this rear axle. We have a leaf spring and this is the shock absorber. Shock absorber, the body of the shock absorber, the coil spring, and this is the shock absorber lower control arm. The shock absorber works best when mounted as close to the spring as possible. So the shock normally McPherson's thread coil spring is surrounded. The shock absorber is surrounded by the coil spring, so they are in a one assembly. So shock absorber work best when mounted as close to the springs as possible. Shock absorber that are mounted straight up and down offer the most dampening. So when they are attached, as like in motorcycle or in your vehicle, in vehicle they are at still slight at angle, but in shock vehicle motorcycle front is a front shock absorber. They are attached to some angle, but the rear one are attached straight one. So shock absorber that are mounted straight up and down offers the most dampening effect. Now, when the vehicle hits a bump in the road, the suspension moves upward. This is called compression or jounce. Suspension move upward, spring compresses. Rebound is when the spring, coil, tension bar or leaf spring returns to its original position. So when the spring releases, it's a rebound. Next, the sixth part of the component of the suspension system is the strut assembly. A strut or sturdy shock absorber that is also a structural component of the suspension. A strut is a suspension link as well as a shock absorber. A casing of a stud must be strong and rigid to function as a suspension link. So the casing of the stud assembly must be strong and rigid enough to work as a function of a suspension link. The shock absorber assembly inside the casing of the stud may be either a removable cartridge or an integral part of the stud. So basically, it's a combination of a coil spring and a shock absorber and a rigid when the casing. But the shock absorber assembly inside the casing of a stud may be either a removable cartridge or an integral part of the stud. The McPherson stud, which is named after Earl S. McPherson, who developed the suspension design in the late 1940s and patented it in 1953, is the most commonly used type. So in our vehicle, normally we see this McPherson stud assembly. A McPherson stud includes the suspension spring, a coil spring that surrounds the stud casing so that it transfers the weight of the body to the wheel. Let's see. Stud assembly. A stud is the structural part of the suspension and includes the spring and the shock absorber in one assembly. So we have this steering knuckle, the yellow one, the lower control ball joint, the lower control arm. The upper steering knuckle is attached to the stud base mount to the knuckle. We have this assembly which is having a coil spring and shock absorber, and this is the upper mounting. So this is your McPherson stud, simple. Consists of a shock absorber, a coil, a spring, consists of a shock absorber, a coil spring, and an upper damper unit. Replace the upper control arm, only the lower control arm and the stud end are needed to support the wheel assembly. So upper control arm is removed and this stud assembly is directly attached with the steering knuckle on the upper steering knuckle upper, and lower part of the steering knuckle is attached with the lower control arm. So let's see this stud assembly. We have this stud retainer, the round net, the ball bearing, the rubber bumpers, the isolators, the coil spring. Then we have the shock absorber rod and shock absorber, the oil. So it's a complete assembly attached to the steering knuckle. Steering knuckle and the lower part of the steering knuckle is attached to the ball joint and the lower control arm. We have this spindle here, and then we have this strut bar and the stabilization bar, and this is the frame of the body. Okay. The last part of the suspension, the component of the suspension system is the track rod. A track rod, also called a panhard rod, is used in the rear of some suspension system to keep the rear axle centered under the center of the vehicle. It is a straight rod or a channel that connects to the frame on one end and the axle to the other end. Used on a rear axle to prevent side-to-side movement during cornering. So it is used a track rod, also called a panhard rod, used in the rear of some suspension system. Rear means with the rear wheels, to keep the rear axle centered under the center of the vehicle. It is a straight rod or a channel that connects to the frame on one end and the axle to the other end. So let's see, this is your frame. It is bar to the axle here and bar to the frame here is bolted. So it is one end is to the frame, one end is to the rear axle or dead axle or the rear wheel axle. So this is how the components of the suspension systems works in a vehicle. So with this, we end to the part 3 of the suspension system. We will talk about these further few topics more on the suspension system, and that is our last part of this chapter 6, that is the suspension. Thank you very much for joining me.